Hey, calculus kids. In this video, what we're going to do is we're going to start looking at trigonometric functions, and we're going to look at the limits of trig functions. Now, I know in 30-1, trig was a really, really big unit. It's not here in calculus, okay? It looks very much like what we've been doing in the last couple of units, right? We're going to find the limits of trig functions, and then we're going to move on into the derivatives of trig functions. So it's not as, in 30-1, it's maybe the most difficult unit, and here it's not, okay? Now, two really important limits that I need you to know for this unit. So the first one's the most important one by far. So the limit as x approaches 0 of sine x over x is equal to 1. Okay, what makes this so important is that we actually use it later on in higher levels of mathematics when we're trying to prove things. And a lot of times we use it in something known as the squeeze theorem. So that's why this one's really, really important. The other thing I want to note about this limit is it works for any multiple angle. So if it's sine of kx over kx, that's also equal to 1, or the reciprocal. So if we flip this limit, right, and it says the limit as x approaches 0 of x over sine x, that's also equal to 1. So something to keep in mind. There is one for cosine. So the limit as theta approaches 0 of cos theta minus 1 divided by theta is equal to 0. This one's not as important. We don't use it as much, but it's just something that you might see from time to time. Okay, so let's go and see what ends up happening with these limits here. All right. So the first one here, I've kind of got the first couple sort of filled in halfway for us. So the first one is the limit as x approaches 0 of sine x over 4x. So that's not quite our limit rule that we just had written above. So what you can see here is what I've done is I've factored a quarter out. And then because that's a constant, friends, a constant using my limit properties can come in front of our limit. And now what we end up with is this limit here goes to 1. And so the limit of this thing is a quarter. What I want you to note, what I'm trying to get at here, is you really are trying to get what's inside these parentheses there. That's what you're trying to get. Okay, sine x over x, or the multiple angle. Okay, so there's that one, not bad. Okay, number 2, so the limit as x approaches 0 of negative sine 3x over x. So right off the bat, as soon as I see this 3x here, this triple angle, what I'm saying to myself is I need this right here to be a 3x. Okay, and so that's the goal for the question. That's what I recognize right off the bat. Okay, first thing I did was I factored out a negative 1. And again, it's a constant, so it can go in front of our limit using our limit properties. But now what I'm saying to myself is, okay, again, I need this 3 down here. So it's sine 3x over 3x. But I can't just multiply the denominator by 3. I would have to multiply the numerator by 3. And that's what I've shown right here. So that little expression we learned when we were, little guys, that what we do to the top, we do to the bottom, is important because it's maintaining equality, right? And so now what do we have? Well, in the denominator, that's what I was trying to get. And this 3 here that's in the numerator, well, again, using my limit properties, I can factor it out front. This whole limit goes to 1. And negative 3 times 1 is negative 3, the kids tell me. Okay, so there's kind of what you're thinking. You're trying to get that multiple angle. And you're trying to say, okay, if that's what's in my multiple angle, that's what I need in the denominator. Okay, on the next one here, I see this 2x. So what that tells me then is I need a 2 down in the denominator. So what I'm going to do, there's more than one way to do this, but I'm going to say really divided by 3, that's 1/3. So I'm going to factor out that 3, like that. And now I'm going to say to myself, well, friends, I need a 2 down here. Well, if I'm going to put a 2 down there in the denominator, then I need to multiply the numerator by 2. So really, I'm multiplying by 1 in that sneaky way. What does that give me? 2/3 the limit as x approaches 0 of sine 2x over 2x. There's that really important limit, and there it is, 2/3. Easy. Now, the next one's got a cosine in it, but what I need you to recognize from 30-1 is all of those lovely identities. 1 minus cos squared is sine squared. So those identities can come back at us again. Okay, so I do need you to think about those. They'll come up every once in a while. And so now what do I have here? Sine squared x over x squared. Well, what this really is, friends, is sine x over sine x, or sorry, try that again, sine x over x times sine x over x. Well, look at those. Those are really looking like our limit. Now, right here, I'm pretty sure most of you could go and say, okay, that's 1 and that's 1. So the limit of this is 1, which I agree with. And I'm fine if you do that. I just need you to be aware that if I was going to do this the kind of quote unquote proper way, my friends, would be to use, again, my limit properties and to turn this into two separate limits. Now, I don't expect you to show me that. I just need you to be aware that if you're looking at a different resource, or maybe when you're off in university, you know, some of your professors might demand that you show every single limit step just like that. But that's it. Okay, friends, so trig limits are a heck of a lot easier and quicker than limits were in our first unit of this course. There it is, not too bad, hey? I will see you another time.